Hello, my name is Ali Amaviska, and I'm an educator at the National Museum of the Marine Corps. Today I want to talk to you about plate tectonics and the role they played in shaping the Middle East. The Middle East is where Marines served during the Gulf War, which lasted from August 2, 1990 to February 28, 1991. To learn about the history of the Marine Corps involvement in the Gulf War, visit our education resource page on our website. Now back to science. The Middle East region, where Marines fought during Operations Desert Shield and Desert Storm, has a fascinating history as seen through its geologic formations, going back 300 million years ago. This video will focus on geology and plate tectonics in the Gulf region and why Marines must take both of these into account while deployed there today. Let's start with the word geology and break it up. Most people think geology is just the study of rocks, but it's so much more than that. The Greek root ology means study of, and the root geo means earth. So the word geology means the study of earth. Earth is way more than just some rocks. Geology studies how the earth was formed and changed over billions of years to create unique environments all over the world. Geology helps us understand the world around us by teaching us about the past, the long time ago past. The past can help us know what to do in the future. Like, where's a good place to build a house or a road? Should we build our house right next to an active volcano? Or maybe right on a place where there's lots of earthquakes? We can figure out things like this with geology. We're going to spend the next few minutes taking you back millions of years to the geology that created the Middle East and the Arabian Peninsula. You may have heard of Pangaea. About 300 million years ago, there weren't separate continents like North America or Africa. All of the land was part of a supercontinent called Pangaea. About 130 million years ago, Pangaea started to break apart. But how did that happen? Continents don't move, do they? Actually, they do. And to figure out how, let's review the layers of the Earth. More specifically, let's look at the middle layer, the mantle. The mantle is liquid hot magma flowing through the Earth underneath the crust that we walk on. As the mantle moves around, it moves the crust above it very slowly. This movement is what changed Pangaea to the Earth that we see today. So we've established that the Earth's crust can move around due to the mantle beneath us. But how does it move, and in what directions? In areas where the crust is really thin, magma may seep out of the mantle and become crust, brand new land. These differences in crust thickness create different plates that move around the Earth very slowly. They move in different directions and at different speeds, and that's why we have 7 unique continents all over the world. Since the plates are still moving, the Earth will look very different 300 million years from now, maybe even a new Pangaea. The study of the way these plates move is called plate tectonics. The different ways tectonic plates can move around each other have different names. When one plate is right next to another plate, it's called a plate boundary. I'm going to show you how these plate boundaries move, first with my hands, and then with a chocolate sandwich cookie. If you need to pause the video to go get yourself a chocolate sandwich cookie for science, do so now. The first plate movement is called convergent. This is when two plates run into each other. This can cause mountains, like the Appalachian Mountains, or the largest mountain in the world, Mount Everest. Convergent plate boundaries make mountains when a land plate meets another land plate. But if one of the plates is an ocean plate, which tends to be thinner, the convergent plate boundary does something called subduction. That's where the ocean plate goes beneath the land plate. Subduction plate boundaries can cause gulfs and trenches, volcanoes, or even earthquakes. The next plate boundary, or way that plates move around each other, is a divergent plate boundary. Divergent plates move away from each other. Divergent plate boundaries can cause seafloor spreading and create new land. Sometimes divergent boundaries even create new seas or oceans. The last boundary we're going to talk about today is a transform plate boundary. Transform plate boundaries move in opposite directions. The San Andreas Fault in California is a transformed plate boundary. Right around the plate boundary, there are lots of earthquakes because of friction. Sometimes these two plates are moving slowly in different directions, and then they just release, causing an earthquake. So to review, everyone grab your chocolate sandwich cookie. Gently pull the top of the cookie off. Refrain from licking the middle because we need that. This cookie is going to represent the top part of our Earth, the crust. The cream filling is the mantle. Now take the top part of the cookie and gently break it in half. It's okay if the break isn't perfect. The Earth's plates aren't perfect either. We're going to review the different types of plate boundaries that we have discussed using this cookie. So first you might remember that we talked about convergent plates. Here, with your sandwich cookie, what I want you to do is take your two different plates and push them together, and as the two land plates meet, they might make a mountain. Next, let's remember the divergent plate boundaries. Here, you have two plates moving away from each other. All right, so as they move, all of that mantle that comes up is brand new land. And last, we have the transform plate boundaries. So you have your two plates here. One is gonna move one way, one is gonna move the other way, and there's gonna be lots and lots of friction, which could create an earthquake. Now let's look at the Middle East, where we conducted Operation Desert Storm. The plate tectonics that form this area are awesome. Around 200 million years ago, Africa started to break away from Pangaea. Back then, the Arabian Peninsula was part of Africa, so it went with it. Then, around 33 million years ago, there was something called uplift. Uplift is when the magma in the mantle starts pushing upwards, pushing and pushing until it finally breaks through. This uplift finally cracked the peninsula off of Africa in a divergent plate movement and formed the Red Sea about 5 million years ago. But it wasn't done there. The brand new tectonic plate moved north until it hit the Eurasian plate, creating a new convergent plate boundary. As the two tectonic plates pushed against each other, mountains formed along the plates. The Red Sea continued to widen and the mountains continued to grow. Those mountains are still growing right now as those convergent plates continue to push into each other. They grow by a few millimeters every year. As the mountains got bigger, the thinner plates subducted under the mountains and created the Persian Gulf around 150,000 years ago. So the Middle East, and specifically the Arabian Peninsula, is still full of tons of tectonic plate movements. You can find all three types of plate boundaries: convergent, divergent, and transform in the area. This makes the region vulnerable to earthquakes, tsunamis, and volcanic eruptions. Because there's so much tectonic activity, people living or staying there have to be very careful about where they build cities and roads, or where they can grow food. Our Marine Corps had to take plate tectonics into consideration when they planned military operations and where military bases and outposts would be built. These plate movements also start to explain why the area is a harsh sandy desert, as you might have seen in pictures of our Marine Corps serving in Saudi Arabia and Kuwait during Operation Desert Storm. Thank you for listening today, and we'll see you in our next Discovery lesson.